Hello, everyone, and welcome to ACS Webinars, connecting you with the best and brightest minds in chemistry and other sciences, live from Washington, D.C. I'm Michael David, and I will be your host for today's broadcast, which we are proudly co-producing with the Science History Institute. Today, we will be joined by a panel of entrepreneurs, architects, and engineers as they present advances in the sustainable use of resources in residential housing that can be applied to both existing and new residential dwellings. And now I'm going to turn the program over to Lisa A. Grissom, who is the Senior Philanthropy Advisor at the Science History Institute.
Thank you, Mike. Welcome to the Science History Institute in Philadelphia and to our Joseph Priestley Society series. We are delighted to be co-producing with the ACS webinars, and we will be taking questions at the end of the panel discussion. It's my pleasure today to introduce our panelists who will be anchoring the program. We have Louis Padullo, President Emeritus, University City Science Center in Philadelphia, who will be the panel moderator. Rob Fleming, Professor and Director of the Sustainable Design Program in the College of Architecture and the Built Environment at Thomas Jefferson University. Edgar Stock, Licensed Architect and Professor in the College of Architecture and the Built Environment at Thomas Jefferson University. Mark Dewey, Managing Partner, Deuce Management, and leader of Project 1851, the building of a tech-integrated and regenerative rental property. And Daryl Boudreau, physicist and member of the Joseph Priestley Society Executive Committee, who will lead the Q&A at the end of the program. I'll now turn the program over to Louis to further introduce the speakers and lead the introduction.
Since we're sponsored by the Science History Institute and the American Chemical Society, I thought I'd give a little bit of a history. I was an electrical engineering professor at Stanford, then became Dean of Engineering at Boston University. Then I was president of the University of Alabama in Huntsville, and then I got to be the CEO of the University City Science Center, which is the world's first business incubator, where with the Ben Franklin program that we started, we helped people start companies, mostly science technology companies. And I didn't have a heck of a lot to do with the environment. I met Mark Dewey, who's on the panel today, because we were both on boards of directors. We were both directors of high-tech companies, mostly biotech type companies. And at one point, Mark showed me his house, which was an old farm. And I saw that not only did he have a grand way to live, but he tried to maintain at least the vestiges of gentleman farming. Now, that means he had livestock, he had horses. He had a daughter who became a veterinarian, specializing in large animals, mainly horses. At one point, I got invited. I got cancer, so I retired from the Science Center quite early. I'm still alive. I still have cancer, but I'm still around. And then I started teaching again. I started teaching product design. I did it for about 10 years at Wharton. And then out of the blue, I got asked to be the founding dean of the College of Architecture and the Built Environment at Philadelphia University, which is now part of Thomas Jefferson University. At that time, one of the programs that we had, my mission was to get us reaccredited in architecture, to set up the structure of this new college that I was the executive dean of, and to have the search for a real permanent dean succeed. All of that worked out really well. One of my star programs there that I inherited and got in good place was run by Rob Fleming, who's one of the speakers today. Rob had a program in sustainability. While educated as an architect and practicing as an architect, he latched on to sustainability as his mission in life, and he was a missionary about it. He was the first friend of mine that had that as his primary activity. And most of the courses that he taught were part-time to existing architects and people in the region. While I was there, I got to meet Edgar Stock. Edgar Stock, who's one of the other panelists, was a professor. To be honest with you, we got a wonderful deal. We hired Edgar and his wife. His wife, Barbara Klinkhammer, was named the dean to be the real dean of the college I was leading, CABE, College of Architecture and the Built Environment. Edgar was a distinguished professor of architecture at University of Tennessee and had a joint appointment with the Oak Ridge National Laboratory, where he worked on really high-tech aspects, let's say material science and electronics and instrumentation, which was unusual for architects. During that year, when I was running the college, I invited Mark and his wife to come out to the various show and tell periods when students would be showing their work. And Mark and his wife really got interested in a lot of the design that they saw. In fact, they hired several of the students there to work on various projects. Among the projects that Mark worked on, one turned out to be a real challenge. And he came to me later on, because we remained friends. He came, and still on a couple of boards together. He came to me with this idea that he wanted to do a real sort of showcase on how you could live well in a sustainable way and cherish environment, not damage it. And so he wanted to take a challenging environmental area, namely one that was under the floodplain and maybe on the banks of this beautiful stream, and see how he might have sort of an eco experience building whereby he could train people, maybe executives or maybe just students, or bring them out there for a retreat where they learned how to coexist with nature using appropriate technology when necessary to not mess anything up. With that in mind, he asked me for help. Did I know anyone? So I just told you the history, since this is the history. Now I'm going to tell you the chemistry. I'm not a contributor here. I'm just the catalyst. But if there's one place on the planet that a catalyst ought to be appreciated, it's the American Chemical Society. So as a catalyst, I pulled together these people, Rod Fleming and Edgar Stock, to work with Mark. Meanwhile, Mark met Darrell Boudreau of the Science History Institute, and Darrell was looking to put programs together. And Mark said, why don't you put a program together about sustainability in residences? Never mind things like the Comcast Tower and people with green roofs on colleges, but people who have residences and where they want to live in consonance with nature. So that's how this program started. Now, with all that as a background, I told you we're going to go right into the presentations. The first person I want to speak is Rob. Now, Rob Fleming, I mentioned to you, was an architect. When he and I were at PhilU and I was promoting him as one of my stars to show off to the world, that's what you do if you're a promoter. Our boss, who was then the president, a former businessman, said to the two of us, he said, hey, it's really cool that you're showcasing Rob with this sustainability, but have you given any thought to the fact that that's a popular flash in the pan, and pretty soon everybody's going to do it? Now, when everybody's doing it, what are you going to have to brag about? And we admitted we hadn't thought of that. And I have to say, to our sorrow, it hasn't happened yet. The world has not all caught on, and sustainability is so second nature to everyone that Rob Fleming still has a perfectly good living ahead of him for many more years. And he's published widely on it. And you'll see links later, and he'll post links to some of the seminars and some of the free videos that he's put together that give you the background on the whole notion of sustainability. So Rob's going to set the stage for us today, and then we'll move on to the next speaker, which will be Edgar, who'll talk about technology, and then we'll go on with Mark, which will talk about essentially the challenge that we're all facing.
Well, thank you, Louis. I appreciate the opportunity. And in fact, I am about to celebrate my 25th year of sustainability education. So I hope you'll all be there for the party. In 2005, a series of events occurred that radically and fundamentally reshaped our relationship to the natural world. It was a time when we finally began to realize that our CO2 emissions would in fact have devastating consequences on our environment and on our way of life. And over the years, we saw more and more disasters happening with greater frequency and with greater impact. And by 2020, I think we all can now begin to agree that this has become one of the existential crises of our time. And I think you would all agree that we need to change, and we need to change fast. Albert Einstein said you can never solve a problem on the level on which it was created, And today I'm going to argue that we need to go on to the next level. And the panelists you'll see after me are doing exactly that. But first, I think we need to step back and think about the way we think. And I think this is why, Louis, it's taken 25 years for us to get to this point, because we're still thinking in the old way. And the first part of doing a net zero energy building, which I'll explain in a minute, is actually changing the way you think. It's very difficult to try to do a net zero building with standard architectural design approaches. And then furthermore, deep down, you've got to change your sense of purpose. What is the reason that you're on the planet? Why are you here? And what role do you have to play in solving one of the greatest challenges of our lifetime? When you do that, your words change and your meetings change and the kind of definitions change. And the words like net zero or carbon negative become part of your vocabulary. And as that happens, it becomes more ingrained in the mission of your life. And then ultimately, you'll begin to collaborate differently. You'll begin to work with people that you never thought possible. So for example, I work with biologists all the time to talk about toxicity in buildings. I work with engineers to talk about how to make PV panels more efficient. I work with clients like Mark Dewey on how to do a better building. And those collaborations require us to be able to think outside of our discipline and keep our eye on the prize of what's really at stake. Eventually, we start to make better choices. We start to decide to become sustainable. And ultimately, we become leaders. When we're doing sustainability, when we're moving these initiatives forward, we're actually leading in the spirit of what humanity needs for us in the 21st century. So this happens to be a net zero building that I worked on a few years ago at Revision Architecture. You'll notice that there's a lot of roof dedicated to solar. You'll notice that the building is in harmony with the environment. You'll notice that there's all kinds of special technologies happening in here, which we'll hear more about later. But how do we get to that net zero building? What were some of the steps that we had to do in order to achieve this? So we first had to agree on a definition. A zero energy building produces enough renewable energy to meet its own annual energy consumption requirements. This is going to become the standard building code within 10 years in Europe and within 15 years in the United States. We are moving to a net zero based economy. The cars that you drive, the buildings you live in, the products that you use will ultimately have a net zero impact on the environment. And then we'll begin to reshape our carbon emissions and how we can begin to really make the changes that we need. So I like to focus on principles. The other panelists are going to really dig into the details of net zero. But today I want to just start you off with some principles. How do you think about net zero? And the first thing you do is you consider all of your options. Should you build new in a city? Should you renovate? Should you build green out in the middle of a wonderful environment? These are questions that have to be carefully considered. Where we build and how we build has a tremendous impact on our carbon footprint. Then we want to consider future adaptability. It's not just designing a house for now that works for the family as is, but what does a building look like that lasts for hundreds of years? And one of the things you want to do is think about how our needs will change. And certainly during the pandemic, of all times, we've seen how radically our lives can change so quickly. And good net zero architecture is going to consider flexibility to make the building last longer. And then we're going to go in and use all of these amazing passive design approaches, things that we've known for centuries. And we've sort of forgotten in our alliance with technology, and now we're rediscovering. The way a building faces the sun or doesn't face the sun has a large impact on the energy footprint of a building, not to mention our own comfort inside the building. So we want to max out all of our passive technologies because we do those once. We put a shading device on a building, we do that once and we have it for years and years and years and years. These are passive technologies that are really critical. And then even before we get to tech, we got to look at the envelope. Air is moving inside and outside of your building at rates that are really causing you to use a lot of heating and cooling for your houses, and therefore emitting lots of CO2 into the atmosphere. And if we can rethink our building envelopes, make them tight, make them efficient, we're going to see tremendous savings and tremendous environmental improvement. And only then, after we've done all of this, do we start to talk about all the cool tech, the HVAC systems, the water reclamation systems, all those kind of heating and cooling things that we love to talk about and think about But really those come very much at the end, after we've done all of these other things that are so important. And finally, at the end, if we do everything right, the number of solar panels that we need to actually get to net zero is very small. And this is really the crux of being a net zero energy designer, is to try to think through this pyramid and make the kind of changes to the way you design so that we can all benefit in the future. Thank you very much.
We'll come back with Q&A a little later, but first we're going to have the initial presentations. And Edgar Stock, please tell us what you do.
Thank you, Rob, for the introduction. So I think you really opened up the floor for talking about sustainability in a broader sense. So sustainability is and net zero really goes from an urban scale to a building scale to a device scale. And I want to present here quickly not only a zero energy building, but an energy plus building. This was a prototypal building built at the University of Tennessee, was in collaboration with Oak Ridge National Laboratories, and it really is sort of a mini test bed to showcase what is possible today to really move forward with energy recovery and technology. So this is really sort of a laboratory building which has two cores and a glass envelope all the way around. It's really meant to be a small, starter home or a unit which can be stackable. So just a few images. Here you can also see already the photovoltaic cell technology floating as a sort of scaffolding above the building. It's a pretty clean glass envelope on both sides. Some of the interior shots. So what you see here is the building has LED lighting in the floor and ceiling, has a super tight building envelope with a quadruple glass pane system, operable windows for natural ventilation, and certainly shading devices. And I'll talk a little bit more about the complex envelope system in a second. So this is a little bit of a introduction into the flow chart, how this building incorporates photovoltaic cell technology, ventilation system for the entire house, a heat pump for heat recovery, and the entire makeup, where everything sort of works with each other to be most efficient in terms of energy usage, but also using the natural resources as much as possible. So the whole house was powered by a 10 kW photovoltaic cell system, and these cells are cylindric. The company was Cylindra, unfortunately went underwater a couple of years ago. Also, we use these cylindric photovoltaic cells as a shading device also for the facade. The facades themselves has two layers and about a foot space in between, and this these two layers, an inner quadruple glass layer and an outer single glass layer, and the space in between really works as a greenhouse or buffer zone. So passive heating and cooling could be achieved through the facade. And then finally, the facade panel was also linked to an air conditioning system or ventilation system. So the passively warm air can be used inside the building for heating or cooling the building. We also used systems like energy recovery ventilators, which is a device which you ventilate your house in winter or summer, and you recover the energy embedded into the air. In summer, you keep the cold air inside, and in summer, so you're ventilating in a way that you're not losing by ventilating energy embedded into the air. So what does that actually mean in terms of savings? So with technologies like energy recovery, tight building envelope, good insulation, this house used only half the energy like a top-notch house built today. So it's a huge energy savings, and with the large photovoltaic system on the roof, at the end of the year, you actually make money by using that technology. So the complexity is really in controlling all these mechanisms, like the photovoltaic cells, the ventilation systems, the blinds, and so forth. So you need a control system to monitor these things and control these. And for example, the blinds. So this is a graph showing that blinds are really important, but if you have blinds, they need to be outside the building or outside the envelope, otherwise they are counterproductive. But coming back to the control mechanism, so if you have all these complex systems in place, you need a dashboard and an easy way to set temperatures, the ventilation modes, and so forth. But we also developed a system which at the same time looks into different lighting schemes, modes. You can control the media, you can track the energy flow and the weather. Because the building we developed also was sort of off the grid with a battery pack system. So with the photovoltaic cells on the roof, we can also power an electric car, an EV car, with the excess energy. And in times when the battery pack in the house was running low, we could use the battery pack from the car to power the house. So energy was flowing back and forth between the building and the car. And because this building was meant to be a showcase or movable laboratory, so it was built on a sort of a steel chassis system, which you can see here. And that house traveled to various locations to showcase the technology and really brings the technology to a typical American. And this was the way the house was transported and traveled through the country. And this is the end of my presentation. Thank you very much for your attention.
I should have pointed out that architects are generally not as tech savvy or interested as Edgar Stock is. Architects are often thought of as designers, and design usually connotes artistic and so forth. Several famous architects, for example, are more like sculptors. They'll think of the first woman who won the Pritzker Prize, I'm blanking on her name now, Zahiv, I think, and then Gary. They'll make some gorgeous thing out of paper mache and then turn it over to their team and say, okay, make that into a building, make it work. So Edgar is really unusual in that he's an architect who really keeps up with the technology and wants to use appropriate technology. Now, ready for Mark Dewey, who I told you was in many ways the originator of this notion. And Mark's going to tell us about this project, which he gave a funny name to, Project 1851. We won't ask him about Project 1850. It probably turned out very successfully, but he'll tell us about Project 1851. Take it away, Mark Dewey.
Thank you very much, Louis. It's a pleasure to be here this afternoon. It's very nice to spend time with Louis and Robert and Edgar. And I wanted to thank Daryl and Monica from the Science the History Institute, who have helped a lot in forming the presentations that we have here today. Louis, Project 1851, not 1850, not 1852, for two reasons. Reason number one is that the address of the building lot that we've chosen for this project is actually 1851 Art School Road, a very historic road in Chester Springs, where both Washington and Lincoln used to walk on, apparently. But 1851 also is a year in which a famous scientist in Paris, Professor Foucault, did a demonstration project, a project where he decided to find a building, a very large, tall building in Paris, one that once had royalty in it, and hung a very four-story pendulum and let it sway so people could see that the pendulum would move in a certain direction over time, proving that against the current understanding of the day, that the Earth actually spins. In the same notion, one of the things I wanted to do, and we are now trying to do with a fully budgeted project and the help of smart people like Edgar and Robert, and the guidance of my mentor Louis, Dr. Padullo, to put together a project where we could be showing and demonstrating in practice the current available technologies that can really make a difference, and where people could consider building houses with these technologies in an integrated fashion rather than a one-off fashion. And so what we wanted to do was to create this dwelling that would demonstrate these things all at one place and be an icon or an example of stewardship and high-performance building design all in one place, and be open, transparent, and have a lot of students from the institutions where, for example, I teach at Westchester University, able to come see and learn about both the fun part, which is seeing technologies work, and the hard part of making decisions and trade-offs financially, staying within a budget, and also working with local authorities, with the compliance and regulatory environment, and dealing with the EPA on, for example, all the way through to the kinds of waste management techniques that are accepted and those that are on the verge of being accepted. And so the idea from a visionary perspective is to work in an eco-friendly environment, but still tech-rich, where we understand the chemistry, understand the biology, understand the physics, to build a sustainable building using these innovative ways of building and having a green existence. Climate change is such that there are some municipalities and even mayors at a recent national meeting where they're considering giving up essentially on certain land and saying, you know, we can't even make it resilient enough to manage the floods and the other kinds of perturbations that are no doubt going to come because of our current lack of international stewardship around climate change. And I felt it was important to pick a piece of land that was not optimal, but actually one that was very challenged from a water and flood perspective. In other words, a subpar piece of land, to be able to show that things can be done from both a regulatory and environmentally sound and technologically appropriate way, even in difficult environments. So the idea is to use it as a template so that other people could come in and learn about all the details and even use it for themselves, if you will, certain techniques, and provide a roadmap for assembling a carbon negative dwelling. And so the main approach, of course, is to use solar. And so we're friendly with the Tesla company. We want to preserve and get points, if you will, for collecting pieces of construction materials from within the 5 and 10 mile radius of the building as much as possible to recycle materials. We've been so very fortunate to have had already many donations, and if you Google Project 1851, you'll be able to provide also free, provide rather, I like to think it might be free, but the materials to help us build so that we don't have to construct and have factories be building things that take up a lot of energy. One example is Brandywine Realty in King of Prussia was taking down a building recently on American Avenue and near Allendale, and they were busting windows, these large 6 foot by 6 foot double thermal double pane windows with some nice tint in them, and they had like over 100 of them. And we asked for permission to go in, and we did get permission. We went and pulled out and preserved some 62 windows. A couple broke. We still have 56 windows, large windows, for building not only this house, but also a greenhouse that will be adjacent to it. Water will be obtained through rainwater using these very interesting water flowers. And for waste management, we'll be doing composting. That way we will not be disturbing the land in this floodplain very much at all. The location, this is now very practical. This is very, very real. It's a 1.1 acre site in historic Chester Springs, and we are currently in the stages of regulatory approval. This is just a site plan here, where the idea is to build a 2,000 square foot building, as well as an adjoining gym that will be creating energy, because all the equipment in there will be creating electricity, and then a greenhouse to minimize the amount of food that would be, of course, trucked in from possibly long distances. This is an example of what it actually looks like. There's an actual stream. You can see from the top left going to the bottom right. This is the worst part of the year. This is in the wintertime. About 97% of this property, except where you might see that little car. You see one little car in there at the bottom left, and that's the part that's not in the floodplain. But generally speaking, by the way, it's quite fine until there's a big storm, in which case there's some water flowing through, and so clearly the house will be on stilts, and we'll have some nice views of the adjoining forest and interesting trees there, as well as a view of the creek. The key thing is that as a demonstration project, we want to have a significant learning palette. We'll offer the opportunity to experience and learn about sustainability leadership. And of course, we're not leading, we're copying, or we're bringing into an integrative environment things that exist and have been designed other places, but bringing them together to coexist and work together. And I'm sure some things will work well and some might not work so well, and we'll be transparent about those things. But having a biophilic and advanced tech house design where each and every time we learn about something new, we're trying to do it like an algebraic equation where like in software we have APIs that you pull in and pull out. We'll try to be able to design it for the future, where as new technology comes online and becomes realistic and available, we'll try to incorporate it. But people can learn about real estate development in challenged geographies instead of running away from these challenges. Building green so that every aspect of the design in the building and the chemistry and biology is considered, so that the impact on the environment today and impact on the environment in 20 years and impact on the environment in 50 years is considered. And then the construction management process itself changes as a function of the perspective that you have on the materials and to what degree they're recyclable. And of course, the overall the greenhouse contributions, positive greenhouse contributions of having and growing food on a year-round basis nearby. So our aspirations are, being a business person and wanting to have KPIs that even going beyond those of educating, sharing, and communicating. We want to have some aspirations that are somewhat more business related. And so the idea is to have it booked 1 year in advance. It's a nonprofit activity, so it's not for the financial component by any means, but to show that it was designed so well that people come, stay for a couple of days, and talk about it so much that the word of mouth is very positive about living in a carbon negative, off the grid kind of environment. We'll be throwing in a Tesla car for people to borrow while they're staying there on the weekend. And the idea too is that have the design so refined and exquisite that individuals will want to come from distances, because our hope is to and a desire is to have it written up in Arkansas Digest or an equivalent communication vehicle of some repute, so that we have to, when we consider each of the decisions that we're making, we're wanting to not make any compromises from design, comfort, et cetera, to be able to meet these important KPIs. This is just an email if you want to get more information on it, as well as anyone that wants to has any questions or want to make contributions can go to the to our website to do so. And we suggest that if you're interested in this journey, it's really on its way, but still the early stages, that please come and provide ideas, and also take away and pull away any and all thoughts and ideas that we're an open book and trying to educate and demonstrate, like Dr. Foucault did in 1851 to show that the Earth was spinning. Today, our Earth is challenged, and we need to be able to take entrepreneurial initiatives to show that we can be doing things differently, and doing so with our conviction and with our pocketbook. Louis, thank you very much.
Thank you. And now we'll have a conversation amongst ourselves. I might ask Rob, many people in sustainability, yourself included, talk about the triple bottom line. Could you tell us what the triple bottom line, and then what your wrinkle on it? Rob is the person I heard say there's really a fourth bottom line. So tell us first of all, what do you mean by triple bottom line? And then tell us the fourth.
Thanks, Louis. This might help answer some of the questions in the chat box. There's a question about how we define sustainability. There's a difference between sustainability as a broad concept and, say, sustainable development, which is very well defined at the United Nations. But we tend to use the term triple bottom line, people, profit, and planet, as a shorthand way to think about a project holistically, so that social equity is reasoned in there. There's some interest in economics, and there's also some major environmental impacts. But being an architect and staying up all night doing drawings for years, I wondered, what role does beauty play in sustainability and sustainable development? If it's beautiful, is it sustainable? And I think this gets to this question also in the chat box about the spirituality and the higher level thinking. And so I would offer that sustainable design could be defined as the quadruple bottom line, which is people, profit, planet, and place. And the idea that your buildings and your initiatives fit into the environment that they are meant to be in.
Mark, what's the most fun thing that you've been encountering in your project, and what's the most vexing part of it?
Oh, Louis, thanks for asking. No doubt the fun part is all the commensurate reading and exposure and discussions with leading authorities in new technology, whether it be in the electrical side or power side, or whether it be in the capture and recycling of water and cleaning of water side of the equation, or in waste management, incineration and composting toilets, for example. Those are all real interesting. Without a doubt, though, dealing with humans, dealing with constraints, and it's clear that the design of our regulatory apparatus, if you will, both from the federal perspective as well as right down to local township level, while everyone is well-meaning, they certainly don't make it easy for introducing new technologies. But that's okay. That's part of the learning process. And in fact, we'll need eventually some forms of, I think, innovation, cultural and regulatory innovation to be able to grease the skids a little bit for new technology so that we can achieve the kinds of green environments that we're heading towards.
I really liked your presentation, and I really liked the way you described how important technology is and what we can achieve actually without even touching technology. We have that discussion all the time that we really have to start with all the passive technologies we can use, proper siding, the orientation of the building, making sure that the building has proper insulation, glass envelopes which are not leaking. And if that is all exhausted, we're really moving forward and embed some high-tech features, which in most cases we probably even don't know, or maybe we don't have the money for. So what's your take on technology versus proper planning?
Is that a question directed to me or to the more smarter professor, Robert?
Either way is fine.
Oh, you want me to go ahead? Okay. Well, I mean, Edgar, I am a person that would like to use technology as the last resort. We have 12,000 years and more of examples of architecture where people have gained comfort without any use of electricity, fossil fuels, using only the sun and the breezes. So I tend to look at technology for me, and by the way, I loved your tech, Edgar, in your presentation. I tend to think about technology as the last thing to think about, as only after you've exhausted every possible vernacular, indigenous, or low-tech option, and then jump into these really cool things that I love to get excited about. That's just sort of my basic approach.
No, I think you're absolutely right. Even with the building I showcased was sort of loaded with high tech, but it was also sort of a spaceship. So the thing testing, how far can you push it, and then you have to trickle back to a normal setting, and to basically have to bring it back to something which is also affordable. At some point you really spend on money for a very little gain. I think you're right. So in general, proper planning can do a lot with basically the same amount of money you would also use for not proper planning. And I think, Mark, that's sort of what you're getting to, that you're not exhausting every single technology. You really want to make sure your building is sited correctly, the orientation to the sun is proper, you have a proper building envelope design and insulation and so forth. So I think that's really the very first step in sustainable design.
Yeah, I think also what is one of the things that Robert pointed out, which I like a lot, is the importance of collaborating in new and different ways to bring technology and or solutions, lower tech solutions. In discussions just last week with Stephen Foley, one of the architects that's helping us, he sat there and he looked at the creek that's nearby, and of course, technology person says, "Oh, let's put something in the creek that turns around to make some energy," and he thought that for hundreds of years people use creeks for a number of things, including cooling. And I thought, Edgar, I would make sure I mention this to you because where he's currently designing a way to get the creek to come in to the house, so that some of the water is moving throughout the house, so that it will be a natural way to cool the house as well as hydrate rooms to a certain level. That makes it as a good example of a relatively low tech way to save money and to live a little bit like the people did a long time ago.
Well, one of the technologies I think we all can embed easily in our houses is really the energy recovery ventilator I mentioned before. It's actually a very affordable device which helps you to bring in fresh air without losing all the energy by opening the window. In winter you lose all the heat, in summer you lose all the cool air. So that is sort of high tech, but it isn't high tech. It's really something you just plug into the wall or as part of your air conditioning unit. And there are actually quite a few technologies now out there we can embed in our houses or retrofit in our houses easily.
Louis, may I
Yes, please.
A couple of questions that I've noticed that the people from the audience have asked. One that intrigues me relative to some of the other things that you have all said is someone asked, and Rob, you might be the one to kick this off the answer to this. What are some feasible, cost-effective renovations that can make an impact on older homes and apartment buildings?
Wow, we go right to the challenging technical questions. And in many cases, Daryl, we have to get behind the walls and see what's behind that drywall or plaster. Older houses were built at a time when heating energy was very cheap. And so there wasn't a lot of emphasis on insulation, and there really wasn't a lot of technology. And so the hard way is to get inside the walls and think about actually re-insulating your house. This is what we call, and Edgar, they do this in Germany a lot, they call this deep retrofits. It's one thing to go with caulk around your windows. That's going to be a good thing, Daryl. But if we can begin to think about really looking at the entire envelope, that's the walls, and then of course the windows would have to be replaced. And many times they don't meet historic standards, hence a challenge. And then we lose our heat through the roof. Any crack in your insulation in your roof waste all of that energy that you spent to heat your building. I would urge the viewer to look at something called deep retrofits. It's something that's going to be coming to the US in a very big way, and I think it's time to embrace that as much as possible.
So what I would actually always suggest is buying a really, really cheap thermal camera which can be attached to your smartphone, and really look at from inside and outside what the temperature gradients are, where you see immediately where cold air comes in, and that's your target. You have to close all the leakage points. The leakages, through the leakages, you lose all the energy, and it doesn't really take a whole lot. A little gap here, a little gap there adds up to like an open window, constantly open window, and you try to heat against that open window. So thermal camera costs $100 at Amazon, and you plug it into your cell phone, and you have enough to really detect leakages in your building.
Yeah, and Edgar, here's where we get the trade-offs in sustainability. Many people care more about human health and the health of the people inside the building. As we make airtight buildings, the materials we choose and the off-gassing from those materials can have effects that are negative. If you have a kid with asthma, for example. So there's a real fine dance between how much do we want to seal our buildings, how much fresh air do we want in, what kind of materials are we choosing, and the interaction between all of these is what makes sustainable design and architecture so difficult. And even for clients, eventually you have to decide on the priorities that you're going to have to emphasize in your project in order to go forward and make decisions.
Someone else asked from a participant from Colorado asked, are there any thoughts on how to create sustainable homes and environments where snow covers roofs and solar panels for much of the year?
I think solar panels actually not an issue even in areas where snow is packing up on the roof, because there's first of all, they're pretty slick, so snow can slide down. They're warming up rather quickly, so they're developing sort of a water film to helps to get rid of the snowpack. If the snow really packs up big, then you have to get on the roof and you have to clear it up. But in most cases, it works actually pretty well. You know, I'm from Germany, and believe it or not, but most roofs in Bavaria have solar roofs, so solar panels on the roofs. So they have a lot of snow. At the same time, they have a lot of blue skies. Colorado is a prime location for PV systems on the roof.
Another question that came up, and I think, Mark, you might be able to have some interesting things to say about this. They were asking about how can we make tiny house options more acceptable to cities, towns, and counties? This is an appropriate question today in Philadelphia, where our city council is grappling with how to possibly make use of tiny houses to settle some of the housing problems for homeless people in the city. Any thoughts, Mark?
I've done a lot of research on tiny houses, and currently are testing out in another project for glamping. How do you make something relatively small that is, now we're talking typically, by the way, in the 400 square foot to 800 square foot range, and include everything that would be normally there, and do so in a cost-effective fashion. And I think that it's in an executive summary fashion that it's clear now that there are ways to build, usually modular approach, which Edgar is a bit of an expert on, and so I should not say too much, but with modular approach and factory built components, where you need not make compromises in luxury or in comfort or in technology, only in size, and keep the overall financial burden quite low. And of course, when you can keep the ongoing cost of maintenance, which often relates to power and water typically, into a close to zero environment, now you're talking about the possibility, Daryl, of having a solution for some of our population that is clearly challenged in having safe environments to live in and be proud of, and still allow some form of ownership, which we all know from a psychological and spiritual perspective is a great advantage to preserving the values that are put there by societies.
Yeah, thank you. And here's one sort of a technical question that intrigued me because I haven't got any idea what the answer might be. The question is whether there is any architectural preference, or what do the architects have preference for, a preference for self-adhered or liquid applied products for net zero architecture. Rob, you're laughing. You take this one.
No, I'm laughing because I have no idea how to answer that question.
That's why I picked it up, because it was an interesting question.
As you're looking there, let me quickly offer a bit of a commentary. One of the things that we consider in a long-term perspective is when we apply things to a surface, is how much it costs to make the application, how long will the application last, and when it starts degrading, how much of an environmental impact does this coating have on the environment? In other words, does it have chemicals or toxins that are going to cause a problem? And of course the other is that once it has come off, the material that it was supposed to protect, for example, if you're talking about a paint or we're talking about similar types of applications, want to know what happens now to the maintenance cost and what happens to the material that's now exposed. Does it start degrading before you get a chance to go in there and fix it up? And so techniques that are, again, going back instead of high tech and using just smart techniques. The Japanese have a method of burning cedar, for example, and then scraping off the black part that you see, the charcoal part, if you will. And then it's been shown and proven that kind of cedar, when properly, without any coating at all, will withstand external weather just as good as CCA treated lumber, for example. And that is an example of a way to deal and move away from coatings altogether.
Another question that that came up had to do with the total carbon footprint associated with many of the ideas that you discussed in your talks. I'm referring to all three of you here, actually. That obviously it's a very difficult question to assess. Maybe we don't even have the right tools to be able to make an assessment or a proper assessment of the total carbon footprint of some of the ideas that you came up with. Obviously, reusing windows that you talked about, Mark, is totally better in terms of total carbon footprint than making new windows. Any thoughts on this, Edgar? How about you? Do you have any thoughts on that?
Yeah, actually, I think you can calculate pretty precisely the carbon footprint of a building. And when I say that, you really have to take the entire life cycle of the building under consideration. So the production of the material, the transport of the material to the site, the assembly, the entire life of the building, and all the energy which goes into the building, as well as then breaking down the material and separating it. So that's sort of the life cycle assessment and carbon footprint of the entire building. And different materials have different carbon footprints. Concrete, for example, is extremely energy hungry and produces a ton of carbon. Steel as well. Wood, on the other hand, is actually carbon positive, so there is embedded carbon in the wood. So there are, by the material choice, you really have a huge impact on the environment. And obviously, global warming is not a myth. I think at the end of the day, pretty much everybody believes now that this is really reality. California is burning since months, so the energy we're pumping out in the environment, carbon footprint really matters. So we all need to really look at our individual carbon footprint, but also the societal carbon footprint.
Being mindful of the time, I know people in the audience have set aside an hour for this program, and we're getting perilously close to the end. I'd like to say that the speakers before we met today suggested that they would be willing to consider the answers to the questions that you have posed that we didn't get to in the discussions today. And we'll try to assemble that and send that out to you by email for those of you who wish to receive that, to all of you who are listening in. We want to thank you all for joining us today. This has been a real pleasure to have the joint group of the ACS and the Science History Institute working together. This is the first program we've done together. It's been a real pleasure from the point of view of the Science History Institute. We hope to be doing more of them. We invite you to our next program, which is on November the 17th. The title is Here Comes the Sun, Advances in Solar Energy. Dr. Vijay Kapoor is an associate at the, he's also a member of the program committee at the Science History Institute, and came to us after he had owned a solar energy company out in California, and he has some very interesting ideas on where this field is going. And so that will be it for today for all of us. Thank you very much again for joining us.
Thank you for watching this presentation. ACS Webinars is provided as a service by the American Chemical Society as your professional source for live weekly discussions and presentations that connect you with subject matter experts and global thought leaders concerning today's relevant professional issues in the chemical sciences, management, and business.